Okay, we're looking at homework problems from last lesson, exercise 6D, question 10. Can someone so exercise 6D, question 10. Decide if the following are true or false and give reasons. Okay, do you want me to look at 10A? Negative 2x squared. What we're going to do, we're looking at question 2A and it's saying decide if the following are true or not. Now negative 2x in brackets all squared means I'm going to look at the left hand side and then I'm going to work out what the right hand side is, okay? So, alright. So negative 2x squared, doesn't that mean, girls, you can do this two ways. It means negative 2x times negative 2x. Are you okay with that? Or not? What does that equal, girls? A negative times a negative. Girls, what's a negative times a negative? And 2 times 2 is 4. X times x is x squared. So that's what negative 2x all squared is. Now the right hand side is negative 2x squared. That means a negative, and then you have to square. So girls, the negative is not squared. Can you see? It's only the 2x that's squared. So it's going to be 2x times 2x. Do you see the difference between them? In this first one, the negative is squared. In the second one, it means that you don't square the negative. In here, you would square whatever's inside the brackets. Now, square means multiply by itself. So negative is out the front, then you work out what 2x times 2x is, which is what? 2 times 2 is 4, x times x is x squared. So girls, those are not equal. 4x squared does not equal negative 4x squared. Do you see that? So therefore, negative 2x all squared is not equal to negative 2x squared. So girls, in the first here, you have to square everything. The negative gets squared. But in the second bit down here, the negative does not get squared. Does that make sense? So girls, it's negative and then square the 2x. Okay, so those two are not equal. But girls, the next one might be. The next one might be equal. So girls, negative 3x cubed, I'm looking at the left, and then I'm going to look at negative 3x cubed. Now girls, doesn't this mean you can cube everything if you want, or you can say that's negative 3x times negative 3x times negative 3x. What does that equal? A negative times a negative times a negative. Negative 27x cubed. Now the next one is telling me negative, and then I do my 3x times 3x times 3x. Or I can just cube it straight away. What do you get here? What's 3 cubed? Or I can use my rules. I can go that times that times that, which is negative. Do the brackets and you get 27x cubed. So girls, in part B, they are equal. What's the difference? Think 10A is false and 10B is true, that they are equal. Why? It's got to do with the powers. 10A is squared. When you square a negative, you get a positive. In 10B, it's cubed, but a negative times a negative times a negative is 3. You know how I'm going minus, minus, minus? Watch. Minus, minus, minus. You end up with a negative if you do 3 negatives multiplied by each other. That's why B works, because you've got the negative. Negative times negative times negative will give you a negative, but we've got negative. 3 cubed is 27, x cubed is x cubed. You'll get a negative on this side as well. That's why it works. Now, just by looking at that idea, do you think C is true or false? Look at the power. It's odd. So on C, on the left-hand side, you're going to end up with a negative or a positive on the left-hand side. Negative. And this will be negative, and what's in here is positive. You're going to get negatives on both sides. So is this one true or false? True. But look at the last one. It's an even power. So on the left-hand side, you're going to get positive or negative. But on the right-hand side, you've got negative of all of this, and all of that will be positive. On the right-hand side, you're going to get Negative. So the last one's false. Even powers. But do you understand how you have to square the negative here? And you have to cube the negative there. But on here, you don't square the negative when you're doing that bit there. And you don't cube the negative here, down here. Yes. Do you see that, girls, or not? All right. Calculator, if you just press the following -2 and then press the x squared button, your calculator will only square the 2 but not square the negative. So you'll get -2 squared is 4. However, on your calculator, if you put the -2 in brackets and then square it, it will know to do -2 times -2 is +4. So it's really important when working with negatives on your calculator that you put them in brackets if you want them squared. Otherwise, it won't. Otherwise, it'll just do -2 squared is 4. The answer is -4. Yes. Asked for homework was exercise 6D, question 8F. Okay. Find the value of A that makes this true. 6A over 7 cubed equals 1,728. Okay, girls. You might want to work out what. So you can try. You know how, for example, what's 2 cubed? 8. What's 3 cubed? 4 cubed, etc. 64. If I said to you, you know that 5 cubed is 125, but what if you don't know what that x is? We know that that's 5. X cubed is 125. How do you go from, isn't x the cubed root of 125? So girls, why don't you do the cubed root of 1728 here and find out what that is? But write that as something cubed. So what I would do, I'm just going to go x cubed is 1728. So x will be the cubed root of 1728. I'll show you why we're doing this in a minute. So someone do the cubed root of 1728. 12. So why don't I write this question like this? I mean, I can do it another way. I'm going to do this a couple of ways for you. 6a over 7 cubed equals, you're telling me the cubed root of 1728 is 12. That equals 12 cubed. No, wait. We're going to do this 2 ways. This is one way of looking at it. Why do you think I did cubed root? Because the left-hand side is cubed. I thought I'd write the right-hand side as something cubed. Now, girls, see how the cubes are the same? That means that 6a divided by 7 equals 12. See, the cubes are the same. All of that's 12. I'm going to do this another way in a minute. I'm going to do it another way in a minute. Girls, do you know why I did cube on this side? This cubed equals, why not make it this cubed? So, if the cubes are the same, then the 12 must equal the 6a over 7. Do you know what to do now? 6a equals, what do I do? Which is 84. So 6a is 84. Therefore, a is 84 divided by 6, which is 14. That's one way of doing it. There is another way. See, girls, I think they want you to do it that way. There is another way. The other way would be to actually solve it. 6a over 7 cubed is 1728. Did anyone cube everything here? 6 cubed is 216, isn't it? A cubed is a cubed. 7 cubed is 343, but it's a bit messier. See how the numbers aren't very nice? So girls, they do prefer that you do it like this, what I've just done. But you might just say, I'm just going to solve the equation. 6 cubed, a cubed over 7 cubed. What would I do now? What would I do now? Move the 343, so I get 2. Can I move this or not really? Can I move down a bit? So I'd go 216a cubed equals 1728 times 343. You okay with that? Do you know why I did that? And so a cubed would be whatever that is. What would I do now? What am I going to do with that 216? Divided by, see how this is very messy? I wouldn't do this. Divided by 216. So I'm just making a cubed the subject, solving for a cubed. Then you get that, and then you've got to cube root it. Can you see how messy it is? I wouldn't do this. What I'm doing over here now, I wouldn't do it. It's not the idea of this question. It'll work, but has anyone worked that out? 1728 times 343 over 216? Anyone? Did anyone do it that way? Do you really want to do it that way? So you can work that out, and then you've got to go, A is the cube root of whatever answer you just got there. No one's helping me with the calculator. Are you happy with the other method? Other method's better. All right? So if you want to pursue this method, you've got to work that all out and do cubed root down here. I wouldn't do it. Okay. Here, square the negative. A negative times a negative is a positive. Then we want 3 squared. Then it's x2 squared, y cubed squared, 2 squared, a to the power of 5 squared, b cubed squared. And the negative got squared, so I lose it, so it'll be 9, x to the power of 4, y to the power of 6 over 4, a to the power of 10, b to the power of 6, and it can't be simplified. So 6k, x squared z over y to the power of 4 times xy squared over z cubed. What should I do with the first? Everything to the power of 4. x2 to the power of 4, z to the power of 4, over y to the power of 4, times x cubed, y squared cubed, over z cubed. Shh. So girls, expanding your brackets, x to the power of 8, z to the power of 4 over y to the power of 4 times x cubed, y to the power of 6 over z cubed. And on the numerator, you've got x to the power of 8 times x to the power of 3 is x to the power of 11. Girls, on the numerator, you've got z to the power of 4, y to the power of 6. Multiplying the denominators, you've got y to the power of 4, z cubed. You can see what cancels. Yes? X to the power of 11, 1z on top, and y squared on top. The denominator will be 1, which is just get rid of the denominator. X to the power of 11, y squared z. Size 6e, question 9a. 2 to the power of x equals 1 over 16. Girls, with this type of question, I've got 2 as my base. I'd like to write 16 with base 2. So that's, what's 16? 2 to the power of what? 4. 4. So girls, can you already see what the, how do you write 1 over 2 to the 4? Isn't that 2 to the power of negative 4? Yes or no? 1 over means negative power. So girls, tell me what x equals. Yeah, because the 2's are the same, so the powers must equal each other. That's how you do question 9a. Let's choose C because of the negative. And we wouldn't want negative 3 to the power of x equals 1 over 81. Girls, this one's a bit of a tricky one. All right, girls, what are you going to do with the 81? I want it 3 to the power of something. Start working it out. What's 3 times 3? What's 9 times 9? So what do you think 81 is? 3 to the power of what? No, it's 3 to the 4. 81, you check on your calculator, is 3 times 3 times 3 times 3. Why? Because 3 times 3 is 9, and the other 3 times 3 is 9, and 9 times 9 is 81. What am I going to do now, girls? How can I write this 3 to the 4, 1 over 3 to the 4 as? How else can I write this? 3 to the what? Negative 4. Here I've got negative 3, and here I've got 3. Now, girls, I'm going to just come over here for a sec. 1 over 3 to the power of 4, because that's an even power, isn't that the same as 1 over negative 3 to the power of 4? Do you see that? You would normally not do this. This is quite tricky. Because, you know why I'm trying to do that, girls? Because over here I've got negative 3 to the power of x. I can't compare 3 to the power of something with negative 3 to the power of something. I need the bases to be the same, and they're not. So, because 3 to the power of 4 gives me the same answer as negative 3 to the power of 4, why does that work? Why does 3 to the power of 4 equal negative 3 to the power of 4? Is even power, and the negative times negative times negative times negative, and my thing's stuck. No, it's not. Yeah, this wouldn't work if it was to the power of 3. So girls, 1 over 3 to the 4 is 3 to the negative 4, but 1 over negative 3 to the 4 is negative 3 to the negative 4. So I'm just going to compare these two outer ones. This is really different. I actually haven't seen a question like this before. So girls, therefore, what does x equal? All right. So girls, quite tricky. Question 9F. Before I do 9F, girls, tell me what 0.2 as a fraction is. 1/5. Do you want to try this one? We can try E if you want. 9E. 0.2 to the power of x equals 25. Girls, 0.2 is 1/5 to the power of x. What do you think you're going to do with the 25? Shh, think of powers. What's 25? Girls, the only thing I can think of with 25 is 5 times 5, which is 5 squared. What we're doing. So girls, 0.2 is 1/5. 25 is 5 squared. What do you think I should write? How should I write my 1/5? Girls, 1 over means negative power. How do I write 1/5 as a negative power? Negative 1 to the x. I suggest you watch, girls. They're getting tricky. Girls, I'm thinking base 5, base 5. We've got to get 5 to the power of something equals 5 to the power of something. What do you do with this negative 1 and x? What's the rule? So what do you get negative 1 times x? So girls, so therefore these are the same. So negative x equals what? What does negative x equal? 2. So therefore x equals? Negative 2. Good. Oh, so clever, girls. 9F. Shh. 3 times 2 to the power of 2x equals 0.75. When you see 0.75, you know what fraction that is. What is it? 1 over 3. 3 over 4. Okay, girls. So let's look at what we've got. I like the 3. We've got a 3 on both sides. I've got a 2 base power here, but I've got a 4 here. I want to change the 4. What are you going to change the 4 to? Think of powers. I don't want a base 4. I need a base 2 here. Yes. 3 over 2 to the power of 2. Why do you think I did that, girls? Because the other side's got 3's and 2's as bases. This one needs 3's and 2's. Girls, I've got 2 to the power of 2x over here, but my 2 to the power of 2 is on the base on the other side. I want to move that up there. What do I do? Good. So that's the same as 3. And if I bring the 2 squared up, it becomes 2 to the power of what? Negative 2. Now, girls, let's compare. The 3's are the same. 2's are the same. Tell me what matches. 2x must equal what? Look at them. 3's are the same. The 2's are the same. That 2x matches with the negative 2. If you compare, I'm comparing position with position. I'm sitting here and say they're a match. They're a match. The 2x must equal the negative 2. Does that make sense? So 2x equals negative 2. So therefore, girls, what's x? 2 times what is negative 2? So therefore, x is negative 1. Okay. It says question 10C, describe the error. The best thing to do is actually just work out what it is, and then you can explain the error. They don't want a sentence here. They want mathematical working then with a little explanation. So I would start with this side here, 3b to the negative 2, and I would write what that means. So I'm starting with my left-hand side, which is this. Because how do I rewrite that? 3b squared. So I'm moving it from the denominator up to the numerator where it would have a positive power now. Opposites. Girls, that's over 1. Are we okay with that? So girls, they moved the b squared up. What did they do wrong? Let's just work it out. So that's 2 times what? What's 3 squared? 9b squared. You can clearly see the problem, girls. They moved the b to the negative 2 up, but they didn't move the 3 to the negative 2 up. Do you get it? And it was, so that's the problem with it. Okay? They only did the b to the negative 2, not the 3 to the negative 2. They didn't move the 3 squared, the 3 to the negative 2 up to make it 3 squared. That's the error. Okay? What you can do is show what the answer should be. So this is what the answer should be. That's another way of describing the error, is to show what should be. Start with G. 4 to the power of 2x equals 64. I'm not going to say anything. I just want you to look at this. Shh, shh, shh. Look how they've done it. They're trying to solve 2 to the power of x is 32. They've said this side has a base 2. I'm going to make the 32 have a base 2, and we just equate the indices. We're using that idea. So let's start with this. 4 to the power of 2x equals 64. I need 4 as my base power. 4 what is 64? 4 cubed. Therefore, are we okay? Therefore, what equals what? 2x equals 3. X equals 3 over 2. That one's fine. The next one you may have a problem with. Girls. 3 to the power of x plus 1 equals... Girls, what don't you do... Girls, just keep going 3 times 3 times 3 times 3 times, see what it is. Anyone? So therefore, x plus 1 equals... So therefore, x is of 2 to the power of 2n. If you want to do a half of 8, you will write 1/2 times 8. So, a half of 2 to the power of 2n. This is question 9. Write it mathematically. How do you write a half? 1 over 2 times 2 to the power of 2n. You tell me what you think you can do with that half. You can. There's a couple of ways you can do this. You can write a half. Why don't we multiply the numerators, multiply the denominators if you want. All right, multiply the numerators. What's 1 times 2 to the power of 2n? Isn't this over 1? What's 2 times 1? Now, 2 means 2 to the power of what? 1 times 2 to the power of 2n is 2 to the power of 2n. 2 times 1 is 2. Girls, 2 can be written as 2 to the power of what? Girls, the bases are the same. What do I do with the 2n and the 1? Girls, bases are the same. What's the rule? Girls, if you had x to the... Thank you. Shh. Girls, it's the same rule. Bases are the same. Subtract the indices. Got it? Now, that's one way of doing it. So one way is to go down like that. The other way, I'll do the blue way, would be to use negative indexes. Girls, 1 over 2 is 2 to the power of negative 1. You okay with that? Times 2 to the power of 2n. So girls, this is one way of doing it. The other way is to write the half as 2 to the power of negative 1. If you write a half as 2 to the power of negative 1, how do you do this? Bases are the same and you're multiplying. What do you do with the negative 1 and the 2n? You add them. So instead of writing negative 1 plus 2n, it looks nicer to write the 2n and then minus 1. It's the same thing. That's like negative 7 plus 5 is 5 minus 7. Same thing. Do you get the idea? Now, so girls, that's two ways of doing that question. This is question 9, and I've done it with two methods, where you're multiplying first and then simplifying by using the division rule. And here, I'm just writing a half as 2 to the negative 1, so I'm doing two methods. And bases are the same, add the indices. Negative 1 plus 2n, you always put your pronumerals before your numbers. So that's the same as 2n plus 2n minus 1, which is just 2n minus 1. Okay, next. Exercise 9.3, question 17. If 2 to the power of x equals 3, evaluate the following. A, 2 to the power of x plus 1. All right, girls. If 2 to the power of x equals 3, evaluate the following. 2 to the power of x plus 1. When you look at this 2 to the power of x plus 1, it seems that two indexes were added. So if I've got this for you, 2 to the power of x times 2 to the power of 5, for example, how do I simplify that? 2 to the power of x plus 5. All right, keeping that in mind, do the reverse here. If I give you that, you can come back to this. So what's that? How do you get 2 to the power of x plus 1? You must have had two bases of 2. One of the powers was x, and the other one must have been 1. So girls, where did that come from? Two indexes have been added. The rule for adding is when you're multiplying indices with the same base, add the indices. So that must have come from 2 to the power of x times 2 to the power of 1. Do you see that? Bases are the same, add the indices. So girls, the substitution is, if 2 to the power of x equals 3, so what do I replace this 2 to the power of x with? Times 2 to the power of 1 is just 2. What's 3 times 2? 6. All right. And I'll just do part C. You have to evaluate 2 to the power of x plus 5. Again, do the same thing. X plus 5, two indices have been added. Where did that come from, girls? 2 to the power of x. What? Girls, that's the question. What question is it? 17. Times 2 to the power of 5. That's where that came from. Two indices were added. Where did it come from? 3 times. So 2 to the power of 5 is 32. 3 times 32 is? All right, I'm going to add something to this. My own bit, that's question. 2 to the power of x minus 3. Where did, girls, indices have not been added this time. Indices have been subtracted. The rule for subtracting indices comes from multiplication or division. So that must be 2 to the x divided by 2 to the power of 3. Now, girls, what's 2 to the power of x equal? 3. So it's 3 divided by, what's 2 cubed? 8. 8. So your answer is 3/8. Got the idea? Good. So there's the negative ones. So I'm going to set you, shh. Oh, okay, that's good. Wait, one more. Shh. Girls, I know I've only got 2 minutes. 2 minutes. Wait, do not go anywhere. Can I turn the page? All right, you sure? All right, over the page. Shh. Same exercise. Shh. If 3 to the power of x equals 10, evaluate 9 to the power of x. Shh. I'm doing question 22a. If 3 to the power of x equals 10, evaluate 9 to the power of x. Girls, we're working with base 3s. 9 to the power of x, how can you rewrite the 9? 3 what? 3 squared. You really need to listen, girls. The problem here is I can't substitute 3 squared. I need to substitute 3 to the power of x. So girls, doesn't this equal 3 to the power of 2x? Doesn't this also equal 3 to the power of 2x? Look what I've done. Girls, you need to look. 3 squared to the power of x, we know we're going to multiply the 2 and the x. That's equal to 3 to the 2x. I'm swapping these. You know why I'm swapping them? Because I want to have 3 to the power of x. Girls, yeah, aren't they both the same? What's x times 2? Isn't that also 2x? When I change it this way, I can make the substitution for 3 to the power of x, which is 10 squared, which is 100. All right? Can you also, part B, evaluate 9 to the power of x? No, not 9. 27 to the power of x. So let's do same question. Same question. If 3 to the x equals 10, do the same thing. Let's go. Girls, what's 27? 3. Girls, evaluate 27 to the power of x if 3 to the power of x is 10. 27 equals 3 cubed to the power of x. What do you do with those? You swap them. Got it? 10 cubed, 1,000. I will email you homework.